So now that you know what like terms are, now we can go further with this, and what we might want to do is combine like terms. Now, since our like terms only differ in their coefficients, it's actually the distributive property that lets us add them together. But that's not how we're going to look at it right now. We're going to keep it very intuitive at this point. So one way to think about combining like terms is to imagine that each variable represents something that can be measured, and you're simply putting them together. So imagine we're packing up our collection of DVDs, and we have two different size boxes. One of them, a larger one, holds Y number of items. That might be 30, might be 35. We don't know, but Y is going to stand for the number of DVDs that we can hold in there. The other box, smaller, holds only X number of items. It's a different number than Y. Again, it can be any value depending upon how big our box happens to be, but we're just going to use X because we don't know how many it is yet. So an expression like this, where it says 6 times Y, could be thought of as saying whatever number fits in a large box, we have 6 full boxes. So we have 6 times the amount that fits in a box. Over here, I have 8 large boxes full. So again, the total number of DVDs packed up there is 8 times whatever can fit in a large box. Over here, I also have more large boxes. I have 4 sets of the large box, so 4 sets of whatever can fit in there. And then you can see that I have 3 times the number that fits in a small box, so I can fill up 3 full boxes. And over here, I've got 5 that aren't in any boxes at all. So if we look at this in terms of a picture, it would look something like this, where we've got our Y boxes here, 6 of them are loose DVDs, our 8 boxes full of the large ones, 3 small and 4 large. And when we combine like terms, really all we're doing is we're putting the things that are the same with each other. And so rather than looking at all those Y terms separate from each other, we're going to look at them all together and say that we have a total of, if we come back up here, 6 plus 8 plus 4 Y's. And so when we add those all together, we end up with 6 plus 8 is 14, and 4 more is 18 times the number that can fit in one box. But we can't forget that we still have 3 times the number in each small box, and we've got those 5 loose ones that aren't in any box at all. So this would be considered a simplified form of the original, because in the original we had 5 terms that were all being added together, and we have now condensed that down to 3. We can't go any further with this because each of these items here now, each of our terms in this expression are not like terms. They're talking about different things. So that's how we know that we've gone as far as we can with combining like terms. Now, distributive property I mentioned in the last slide, we need to know what that is before we can see how that helps us with combining like terms. So let's continue on our example of the DVDs. We've got our large box that holds Y number of DVDs and our small box that holds X number of DVDs. So right here, this expression could say that we have 5 small boxes full. So the total number of DVDs is 5 times whatever's in a small box. And we have 3 large boxes. So the number of DVDs there is 3 times whatever's in a large box. And then we have 6 loose DVDs, not in any box at all. And these are all in our car. And so that would look something like this right here. If I were to draw it out with pictures, 5 boxes that are small, 3 boxes that are large, and 6 loose DVDs. Now imagine that we make 8 trips with our car that's loaded up exactly the same every single time. Basically what that means is this load right here, our 5x plus 3y plus 6, we want to have that 8 times. So the distributive property tells us that we can actually simplify this even though we don't know what x and y are. It says that if I'm going to draw this picture 8 times, I'm essentially going to have something that looks like this. I'm going to have my 5x's 8 times, or in other words, I'll have a total of 40 x's when I draw the picture out. And I'll have my 3 y's a total of 8 times. So I'll have a total of 24 y's when I draw the picture. And finally, those 6 loose DVDs, I'll also have that 8 times, and so I'll have a total of 48 loose DVDs. So if I went through and organized this picture and put all the x's together, you'd see that I have 40 x's and 24 y's and then 48 of the constant. Now, distributive property can also help us do mental math. For example, if we're trying to multiply 8 times 24, you might not be able to do that in your head, and you would probably pull out a piece of paper or a calculator, and you would do this kind of multiplication here. You'd say 8 times 4 is 32. You'd carry the 3, and then you go 8 times 2 is 16. You'd add the 3 and get 19 and end up with 192. That's really what's going on here. When we say that 24, think of it like money. 24 is 2 $10 bills and then 4 $1 bills. And when we do that 8 times, I'm going to have 8 sets of those $20 and I'll have 8 sets of those $4. These are easier multiplications to do. I can just take 8 times 2 and I know that there's going to be a 0 at the end because it's 2 10s, 20. And then 8 times 4 is 32 and I can add them back together. Notice that I can do this even with some that look a little bit more complex, like 7 times 39. I don't have to say that 39 is 30 plus 9. I'm going to think of it as 40 minus 1. Or in other words, I go to the clerk and I give them $40 worth for this item, and they're going to give me back $1. So if we do that 7 times for the 7 items, I'm going to give them $40 7 times, and they're going to give me back $1 7 times. So with the subtraction in here, that subtraction carries down because the subtract 1 happens 7 times. And again, you can see how I'll get 280, and I'll subtract 7, and that'll give me 273. Same as if I multiplied it out by hand. If we take that last problem that we looked at before with the pictures, where we had the 5 small boxes, the 3 big boxes, and the 6 loose DVDs, we can use our distributive property concept as above right here by saying, I'm going to take the 8 times the 5x, and so that's shown right here, and then I need to add the 8 times the 3y, that's shown right here, and then I need to add the 8 times the 6, and so I show that right here. Now, some students are confused because they're thinking we can only add like terms. But this is multiplication, and this 5x means 5 times the number in each box. So we can separate that multiplication and then regroup it. That's our associative property that allows us to regroup multiplication and say that this is the same as 40 times x. Same thing here, we can ungroup and regroup and get 24 times y, and then the 48 on the end, and we get the same answer that we did doing it the other way.